Alright, here we go, section 2.5, least common multiple. Okay, gonna come in here and find the LCM of a set of counting numbers using prime factorizations and find equivalent fractions. Okay, jumping down here. Least common multiple. The least common multiple of two or more whole numbers is the smallest number that is the multiple of each of these numbers. Okay, how we're going to do this? Find the prime factorization of each number. Okay, list the prime factors that appear in any of the prime factorizations and find the product of these primes using each prime the most number of times it appears in any one of the prime factorizations. Let's go over here to the example they just give us so we kind of see this. Okay, find the least common multiple of 20 and 45. Okay, prime factorizations. Notice the prime factorization of 20 is going to be 2 times 2 times 5. So that's going to be 2 2's and 1 5. Here we have 3 times 3, 2 3's, and 1 5. Okay, step 2. Okay, 2, 3, and 5 are the only prime factors because notice we have a 2 here, a 3, and a 5. Okay, so continuing on. Okay, we know how to prime factorize, then we just kind of list out what we got here. Okay, the most number of times each prime factor appears in any one factorization. 2 2's in the 20. 2 3's in 45, and 1 5 in all of them. So notice here, so the LCM is going to be 2 times 2, 3 times 3, and 5. Okay, so 180 is the smallest number divisible by both 20 and 45. Okay, and it says note also that the LCM 180 contains all the factors of the numbers 20 and 45. What we're trying to do here, the least common multiple, is you're going to see this a lot. This is going to be something you're just going to have to learn. Okay, some of them are going to stand out to you. Okay, some are just going to kind of pop right out, and that works great. Other times, like this one, it helps to do the factorization of it. So coming in here, let's do an example. Okay, we're going to find LCM of 12, 18, and 48. Okay, first off, we're going to do is we're going to prime factorize this 12. Okay, let me come in here. Okay, the prime factorization of 12 is 2 times 2 times 3. Okay, and then for 18, we're going to have 2 times 3 times 3. And then for 48, we're going to have 2 times 2 times 2 times 2 times 3. Okay, so notice here we have 2 2's, and then we only have 1 3. Okay, here we have 1 2 and 2 3's. Here we have 4 2's and just 1 3. So as it states right here, notice only 2 and 3 are the only prime factors. We don't have a 5, we don't have anything else. Okay, we don't have a 7, it's just 2's and 3's. So let's come to the next page here. The most number of times each factor in any one factorization. Okay, looking closely at this, let's remember, going back to our last page, we got to look for the most times a number happens. Notice here in the 2's, that happens 4 times here, only once here, twice there. So on 2's, I've got 4 2's. So there's one there. Now notice for the 3's, it's on the 18, and I've got 2, okay, sets of 3's there. So let's remember that. Coming over here, notice I have 4 2's, okay, and then I have 2 3's. So putting that all together, I can get 2 times 2 times 2 times 2, there's my 2's, and then I'll do my 3's, 3 times 3. Okay, when I do all of that and I put it all together, I get 144. Okay, so with these numbers, 12, 18, and 48, my least common multiple is going to be 144. And let's remember that. What we're saying here, this least common multiple is if I started going by multiples of 12, I started going 12, 24, 36, dot, dot, dot. Eventually, I'm going to get to 144. It's going to be the same thing with 18. I can go 18, dot dot dot, and eventually I'm going to get to 144. And then the same thing with 48. I'll just come here and just go dot dot dot. Eventually I'm going to get to 144, and this is going to be the time when they finally all match, and this is the least time that they're finally going to match. It's going to be at 144. Notice this is a lot easier of a method than trying to go, well, how far do I need to go before they all match? Another thing some people do is they multiply them all together. Problem being with that, though, is you're going to get an insanely large number sometimes. Okay, so you got to be careful when doing that. So let's continue on. We'll do another example here. Okay, we're going to look for the LCM of 36, 24, and 48. Notice these are one of those that if you multiply them all together, you're going to get a really large number, which is not going to help you later on once you see where this is kind of coming in. Okay, so let's look at the prime factorization of 36 first. And what we got here is we've got 2 times 2 times 3 times 3. And then for 24, we're going to have 2 times 2 times 2 times 3. And then for 48, we're going to have 2 times 2 times 2 times 2 times 3. So notice we just have 2 and 3 here for prime factors, for the prime factors, 2 and 3. So do we have any, what's our greatest amount of 2's? Notice it's right here. So right here we're going to have 4 2's. Okay, well how about 3's? Well, I've got 1 3 here, 1 3 here, and then notice here I've got 2 3's. Okay, so I've got 2 3's. And this is very much reminiscent of our last problem. Okay, so when I come over here, notice that in the 48, we ended, what did we have in 48? We had 4 2's. Okay, so we can put in here 4 2's. And then the 36, well, going back, we had the 2 3's. We had 2 3's. So the LCM is going to be 2 times 2 times 2 times 2 times 3 times 3. Okay, all of that. Well, just like on the last one, remember, okay, we've done this one like this before. You end up getting 144. So 144 is the smallest number divisible by all of these numbers right here. And I promise you, this is something you're going to want to really practice at and get really, really good at. It's going to help you in the long run, especially when we start trying to get rid of fractions. Okay, because this does help us kind of remove fractions later on. So let's continue on. Okay, find the LCM of 8 and 25. Well, notice we've already went in here, we've already did the prime factorization of 8. We've already done the prime factorization of 5. Okay, notice in this case where the two numbers have no common prime factors, okay, the LCM is the product of the two numbers, which basically it's saying we're going to multiply all of this by all of this, okay, or we would just multiply those together. This is the process I was talking about where we would come in and just start going where you can multiply them all together to find the LCM. The only trick is with this one is doing that with some numbers, like I said, it's going to be a very large number. But the LCM of this one is going to end up being 200, okay? Which you can get by multiplying these two together or by multiplying all of that together. It's really up to you. Let's continue on. Okay, find the LCM for 12, 18, and 66. Then state how many times each number divides into the LCM. Okay, notice we've already got the LCMs here. We've got 2 times 2 times 3, 2, 3, and 3, 2, 3, and 11. So our LCM, notice we got to look for the largest number in each one. Okay, so the prime factors of this are 2, 3, and 11. Well, notice here I have 2 2's, I have 2 3's, but then I've also got this 1 11. So to prime factorize this guy, I'm gonna have to come in here and go, okay, well 2 times 2 times 3 times 3 times 11. So 2 times 2 times 3 times 3 times 11 gives me 396. So 396 is the LCM of this guy. Coming over here to the next page, we'll rewrite everything and notice that we've got our LCM of 396 that we figured out. Okay, and then we have the numbers. Let's see here. We had 12, 18, and 66. So we have 12, 18, and 66. And they want to find out, okay, how many times will 12 go into 396, 18, so on and so forth. So I've got 396 divided by 12. I'm also going to have 396 divided by 18, and then 396 divided by 18 is what, divided by 66 on this last one. Okay, well, 396 divided by 12 is going to give me 33. 396 divided by 18 is going to give me 22, and 396 divided by 66 is going to give me a 6. Okay, so each one of our little numbers here, each one of our numbers will divide into 396 at the appropriate times. Once again, this is going to be something else that you're going to want to get pretty good at. Okay, to find a fraction equivalent to a over b, multiply the numerator and the denominator by the same non-zero whole number. Okay, a little blue line there, where a over b equals a over b times k over k. K over k is just a constant number, like it'd be like 2 over 2. Okay, equals a over b times this constant here. And notice here where it says b and k can't be 0, obviously, because we cannot have a 0 in the denominator. So for example, 2/3 is equal to 2/3 times 5 over 5. Well, that equals 10 over 15. Being that if we reduce this guy back out, notice if I go ahead and prime factorize this guy, well, that's going to be 2 times 5, and then that's going to be a 3 times 5. The 5's cancel out, and notice I'm back to my 2/3. Okay? So come in here, find the missing numerator that will make the fractions equivalent. Solution. Notice it's going to be 7, because if I have this 7 here, okay, it's going to be equivalent here, because if I do 3 over 4 multiplied by 7 over 7, well, notice on the bottom I get the 28 here, okay, and then on top I get 21. So this right here is an equivalent fraction to this guy right here. We're just multiplying it by a constant, same constant, top and bottom. Okay, same thing over here. We'll look at this one. Okay, find the missing numerator that will make the fractions equivalent. I've got 9 over 10 equals something over 30. Okay, well, notice here, because 10 times 3 equals 30, then we're going to multiply everything by 3 over 3. And that's exactly what they're showing us here. This 9 over 10 is an equivalent fraction to 27 over 30, because we just multiplied everything by 3.